Okay, what I forgot to show is this reference that I use for these hubs that I'm building tools for. So on eTrailer.com you can see the most common ones that you're going to see is the, well, as long as it's 5 lug, there's 4 on 4 inch. It's probably the most common small ones. I haven't built one of those because I don't need that one, but I can build it if somebody happens to need one, or if I ever need one, I can build that. 5 on 4 3/4 is probably not real common, but let me get down here and I'll show you kind of better pictures of this. So 3,500 pound axle, or even some, that are 1,500, 2,000. The most common is going to be your 5 inch on 4.5 bolt circles. So that's one of them I've already built. I've built a lot of these, and the 6 on 5.5 is like 5,200 pound axle on my travel trailer. So I've already built that one. And if you look in here, you can find those dimensions too, like of how that fits. But just for these tools I'm building, if you can get close enough, even over the lug nuts, you can line them up and see what you've got. And here's going to be that most common 5 on 4.5 bolt circle. And then the one we're doing right now is this one, 8 inch, or 8 lug on 6.5 inch. And notice it talks about 1/2 inch studs. And there's pictures of these, and you can open them up. They have a range of axles. I think my trailer is considered 7,500 pound axles. And anyway, there's a lot of different ones of those, but that's the bolt circle. You can click on this to get more information and to even see this stuff up closer. See how that fits on where I was saying I made that 5 inches. This is supposed to be 4 3/4 to where that wheel fits around that hub. So anyway, I just wanted to show you that's kind of the reference that I'm using to see these different ones that are the most common ones, which I have 3 trailers. The 5 on 4.5 is my smaller trailer. I haul all of my lawnmowers and things on, which was an old boat trailer that I built into a utility trailer. And then, like I said, my 6 lug is my travel trailer. And then the 8 lug that we saw here is my big 8.5. My 8 lug on my gooseneck car hauler trailer, 24-foot gooseneck. It's a 15,000 gross trailer, so I assume that means they're 7,500 pound axles, 2 axles, single rear wheel top axles. So anyway, I just wanted to show this on what we're about to build, so you kind of have a feeling of what we're talking about. If you're trying to find your bolt pattern for your wheels or your hubs, or sometimes it helps you to find out what wheel bearings fit different ones, at least to give you an idea of what might be in there and something like that. So you can use some of this reference here on eTrailer to find the part numbers on your wheel bearings too. And they sell all those things, and I sometimes buy from eTrailer. Sometimes I use it just for reference and get my bearings wherever I can the fastest usually. But they do a good job of shipping things to me when I do need it. So anyway, that's what I wanted to show you, what we're building here, and let's get on with the rest of this video. Alright, good morning. I was just going to show you how I draw a few things to use on 3D printing, and you can also, I've shown this before, use things on for plasma cutting or any other reason you need to draw something. This is my Cut2D software I've used for a long time that I really like, but it's not real good for 3D printing. I'll show you what I've learned about that. Of course, the cat's over here griping about something. Lay down and quit worrying about it. Okay, let's just see here. Let's just create a new file. I'll try to go through this as quick as I can, and if it's helpful to anybody, that's great. And if you have any questions, holler at me and see if I can clear anything up, because I'm not that great at this, but I can do it. So in this case, I'll try to show you at the end of this what I've made and what I'm kind of working on a little bit. So just making some templates to check like some of my trailers or different bolt patterns. So first off, well, let me go slow. This is laid out so easy. I've showed this before. But here's the shape. We just need a circle or a few circles. And I'm going to put these circles down in here in the 0 point, just so we can measure off of them if we need to or whatever. The first diameter we'll use is, it's a 6.5 inch bolt pattern, so let's do that first. Give us something to line our, this is where the bolt pattern will line up on that to start with. And then we need our OD and then our ID circle. So I think about 1.5 inches will give me some room. So let's come down to 5 inches to go on the ID, because I believe the hub that fits around is about 4 3/4, so give us a little room just to do that. And then let's go 1.5 inches bigger on the OD. I'll show you why maybe in a minute. So we're at 6.5, so let's go up to 8 inches on the OD. All right, there's 3 circles. Oh, I need one more, don't I? Forgot. We need one here. You know, I wished I could put one at about a 22.5 degree, but I don't want to get technical right now. I'll tell you kind of why. I've already done a bunch of these, so this one's got 6 holes. No, 8. I forgot about it. This is an 8 hole on my big gooseneck trailer. Man, burning at something. Getting in my eye. Okay. Let's just make one that's 8. I've already done that. Now I need the stud size is 1/2 inch, so I've been going about 50 thousandths bigger than that. Just to make sure we got room to slip it on there easily. I put that in the middle like a dummy. Let me back up. I just want to put it up here on this, just in line with our center line there. So now there's our circles we can work with real quick. And again, this way of doing it here is not the best way for 3D printing. It works fine if you're doing a plasma cutting, and you can make these with the plasma cutter just as well. So now we need to copy that in a circle. So let's just highlight that one we're working with for now. Go down here where it says, I think it says circular copy. And I already put this in. There's a number of items. You can put as many or however many you need. I've made some 5 lug, 6 lug, and then this is an 8 lug. Our rotation center, let's just use our 0. See, that says X0 and Y0, and here is where that is. Will be what we're rotating around. This object size is just telling what size that is. So we're going 360 degrees. Let's push copy and see what it does. All right, there we go. We have them all now. But see, now we don't need this line on there anymore. We've used it for what its purpose was. So we'll delete that line, and there's our little flange that I now can move to our corner 0, where I like to keep things sitting when I save files and stuff. So there we go. So there is what we're going to build. Now I don't like that this is here, because I want to put text in here of what size this is, just so on my tool, this is a tool I'm making, I usually mark what each one is so I know that. I don't have to come back and remeasure or anything. So in that case, I like to rotate this. I believe that would be 22.5 degrees to put this flat on top. I just rotate the whole thing. You could rotate the bolt pattern, but let's rotate the whole item. Right here is the rotate tool. So let's do a relative rotate to, let's just call it 22.5 degrees. Bam. So there we are. Now we have that flat spot to work off of. Now I found out you can put text in here. You know, it just doesn't really help us. You know, if we was to put that in here, anyway, I don't want to do this. I can use it on this, and on plasma cutting that would be fine, but you're going to have holes you're cutting through it, and it's a little different deal than 3D printing. So let's not do that for now, and we'll just save this, you know, save it, export it, whatever. So let's export this as a DXF and just call it our 8 lug template. I've already saved this under different things I was playing with earlier, so let's call it 8 lug template, and that's going in my 3D folder. So let's just save that and get out of this. I don't want to save it as a CAD file here. So we're done with that program, but let me show you another way to do this. That's really the best way. But before we do, let me show you. This is Fusion 360. Let's go ahead and pull up that file we just made. So let's just say open from the computer. It should be in here, 8 lug template right there. That's the one we just created. So let's just put that on the top like that. So that's what we made. Now to 3D print this, all I gotta do is highlight this thing here and then just push extrude. I don't use hotkeys much. I think you can push E. And right here it's going to say how much do you want to. Let's go 0.2 inches and then I'll hit enter. So now that's what we've got. It's an extruded 3D, basically a 3D drawing, right? So I also got some work I can do on this, but I don't really want to do that on this particular one. But we could just, for the fact, see how I've got the holes this way, that way I have room. On this one, you can click the face here you're going to put a sketch on. You can come down here to create a sketch, and then come down to text. And then what it makes you do is select where you want it to be. So I just kind of guess there's probably a better way of doing that. And then in this case, I would just put in something like 6.5, because that's the size, 6.5 inch bolt circle. And then I'll just say, okay, I can select, that's a little different font. You can select different fonts. And say okay, and finish that sketch. So now I can extrude that. I just click on that, extrude, and I'm going to put a negative number because I'd rather kind of do a negative letter into the material. It's easier to read, it seems like. You can make it stick up if you wanted, but I just think it looks better and it's easier to read on black. This is a black material I'm using. I'll put negative about a 1/16 of an inch, minus 0.06, enter, and now we've got it done right there. See, there's the letters that are going to cut down into that. And there's some other work I was going to show you to do the chamfers here and everything like that. So for now, I don't want to do that, so I'm just going to close this out and start a new design here. It kind of saves it here for you, but I don't care. So now let's just say we want to do the whole thing in Fusion 360. To me, Fusion 360 takes a lot to learn. I've heard people say it's an easy program. I don't consider it easy. I'm not, you know, I'm a machinist and a mechanic and different things like that. I work with my hands. I'm not in an office all day. So CAD work comes to me as needed, and when I need it, I use it, and I'm not that great at it, okay? So I usually have to ask my son or somebody for help. My son's a draftsman, the same business I work at. So it's nice to have somebody to help you on stuff like that. So anyway, let's just create this from scratch. So if we go to create a sketch, on this, you pretty much pick where you want to put it. I like to use the top. I've heard people say that's not the correct way to do it, but as far as people that do CAD drawings, it's just how I operate, and I work off the top when I'm doing machine work or 3D printing or anything else. So let's pick a circle, and this one you just go in the middle and drag it out, and then you have to pick what size. So remember that was a 6.5 bolt circle. I'm just going to hit 6.5 enter, and see, this doesn't put it somewhere that you know where that's at on this page. This is one thing I don't care for on this. I mean, it's just not what I'm used to. So that's a little different for me. So there's 6.5. Let's do another circle. I believe we made that 8 inches, so we're going to put 8.0. And another circle. Oh, we got to select the tool again. In the center, we made that 5 inches, right? So there's our 3, and then we need the lug. And I'm not good at rotating this, so I really wish I could just put that at that angle to start with. There might be a way to do that. I don't know what it would be. Let's just put it right over here. I don't think that's going to help us any. And we're going to put that at 0.55, okay? So there's all of our circles, and then we can, I think while we're still in this sketch, we can look down here for circular pattern. And I think I'm still highlighted, but let me click that. Okay, that's highlighted. We can select that object. Now let's select the center point of rotation. And then all we've got to do is pick how many we want. See, it's drawing them as we go. There's 8 of them. And say, okay. See, now that I've learned how to do this, it's not looking like it's that hard, is it? But it took me a good bit to figure out how to use this software. It's not that simple. But it is a pretty good software. It's one I want to learn a lot more about. So now, just like earlier, I don't need that line, so I'll delete that line, okay? So now here we go with pretty much what we had on the other one. And maybe you might think this is an easier software because it seemed like it was, didn't it? Because I went right through it. And it probably is if you're used to CAD software, but I'm just showing you how I've learned to navigate the things I do. So you can push this to see it, but as you can see, it's not extruded yet. So let's go ahead and extrude that like we did earlier to a 0.2 inch thickness. And what I need now is to figure out how to make this rotate 22.5 degrees. And I'm not sure. I'm just going to mark all this. I think it's in this modified. I don't know if I can figure this out or not. Let's try it. I think it's in this move copy function. And see, this says rotate. So, not sure how to do that. It says axis select. I don't know if you can just pick a round spot. And there it's saying degrees. So let's try to put 22.5 in there. It looks like it did, and push OK. So yeah, I guess it can be fairly easy here. I wasn't even sure how to do that, and I figured it out. See, so I mean, I've studied into it a little bit earlier, and watched some videos. That's a good thing. Either one of these softwares I'm showing you, there's plenty of YouTube videos of people showing how to use these softwares. But to me, Fusion's a whole lot more advanced, and there's a lot more stuff to learn in it. So I would recommend, if you don't need the 3D shapes, I wouldn't be using Fusion. I would use the Vectric software for normal 2D drawings if you don't ever need to extrude or do anything like that. So now what I want to do, remember I want to put that text, so let's turn this back up here and let's put our text box in and get this where I can see it good. So let's go in here to create a sketch and then go down here. Oh, I got to pick where I want the sketch. So it's going to be on this surface. And then we're going to go down to text. And let's try to halfway center. I don't know a good way to do this part. I haven't learned that. So I just eyeball it. And let's just say we'll put it right there. And just like before, let's type in 6 1/2. And it looks pretty decent centered. You can play with a line top, middle, or whatever. If I want to move that up, that's too high, isn't it? So move it to the middle is a little better. You can do left and right. It looks okay to me right there. So let's just say okay, finish that sketch. Now let's highlight it and go back to the extrude function, and let's do a negative of 0.06, just like earlier I did. And so now there's the letters in there. So you can see they're cut away into the material, about 60,000 sticks. Now I want to do some chamfers, and this is pretty easy. So the best thing to do first is you can see through this kind of and select. So I want to select. Now you push the shift to add anything else. Click it the first time, then start pushing shift. Same way on my other program. So see, I can see those edges by just hovering over them. There's that top edge, bottom edge. I'm sure anybody that knows how to use Fusion would tell me that all of this is a waste of time and everything. I don't know much I'm saying about how to use the software. I know enough to do what I do with it. And yes, I'm sure there's a way to tell it to select the holes and automatically do stuff. I don't know how to do any of that. I'm going to get the outside chamfer, and then I can see the bottom one. I guess that's it right there. So now I'm going to go here to modify, and I'm going to select chamfer right there. And there's a box up here, and I'm just going to put something like 30,000 chamfer. Like that. I just want a little deburring type action, really. And we'll push OK. So see, we have all the chamfers drawn in there, and they're on both sides. Remember, I did that over here too. So they're everywhere I want them, and that just to eliminate any sharp edges or just to make it look a little nicer. And where these will slide over the bolt holes easier because they've got a little chamfer. And I shouldn't have to touch it or anything. It will just 3D print just like that. And you know, if you were doing a milling operation, I guess you haven't learned how to create those programs yet on here, but very well. I've done a little bit of that. And then I guess that would also let it mill those the way you draw it as well. So at this point, here's the part that you do. I've found out if you do this in other programs on a circle, you'll see those funny lines like you see right there. It's kind of like little triangles all put together. It's hard to explain that unless you've done it, but you know, on 3D print you'll see a circle that has a bunch of faceted type edges or something. This seems to help that. If you go right here to File and go 3D print, this pulls up my software but you got to click this. You can preview this mesh. It's kind of showing what it, I guess how the structure of the drawing is, I guess. So, and I've got it set on refinement is high. There's high, medium, low, and all this. I think that's the quality of how fine the drawing is, I guess, therefore. Now let's just push OK. And that's going to open up my, what they call a slicer software, which is like a CAM software. If you were milling or routing or something, that's kind of like a CAM software. So, it pulled it in here. I've got quite a bit of software open, so it took just a second there. You can look at this to make sure there's no problems with how it's going to do this underneath. Anyway, that's kind of how it's going to be when it prints. See that there's our cutaway letters there. I think they're called de-embossed. Is kind of what that's called, I think. But so anyway, let's just push. Let me get my USB right quick. Although I'm already printing this, I don't know if you hear that in the background. I actually did one of these earlier and I printed it. I actually think this one turned out better. I mean, it may be about the same, I don't know. But all I do is I plug in my USB here. It's got a little SD card in it. A USB adapter to a micro SD card that goes to the 3D print. So, and then it just tries to open this up. I don't need that right now. So I'm going to push slice. Because I've already got my settings in this of how I want it. This is doing a 40% infill. And you can preview this and kind of see, like if you wanted to see different layers here of how it's going to do. And you can push this play button over here or something. I'm not sure. But anyway, as it's working, enlarge this a little bit for you so you can see how the infill layers work. This circle around it is just where it kind of primes the nozzle of the 3D printer. It makes a few paths around there, and that way you can look at it and make sure it looks like it's, you know, adhering to the glass plate good, and it's, you know, everything looks level because the thickness looks right everywhere, and giving it some time for that nozzle to really purge anything out of it and make sure it's extruding the material out real well. And then here's the levels. You see the infill that it does there. See the basically little hollow spots during the layers that it's making. And then it starts getting to finer layers so you get a little better finish on the top. And you can do more settings in there to make it even better. But my finish is not real great on the top. The bottom's pretty good because it's against a flat surface, but it ain't bad. I'll show some to you here in a minute when I get them out of there. But so I'm just gonna save this to my drive. I saved it under a goofy name though, it's gonna be wrong. I usually go right over here. If anybody's watching this that does this kind of work, I go right here and I'll save that file to what I want it to be. So that's what I didn't do there. You know, like I would put like an eight lug template is what I would do, and then I would say, save it. So now it's saved. And then I would just close this, and you know, I would save this. STL file is normally, but there's a lot to go through to save these. You can just click save and then name it 8 lug template or whatever. 8 lug by 6, 5. Yeah, I don't think you put a decimal in a. I could put the word 6/2. Something like that, and just push save. And after you save that, it kind of goes through the cloud to do this, so it's a little bit slow when you do this, but then you can go export. Just use that same file name and tell it that you want an STL file right here. In case you're confused, that I went through the 3D print thing up here earlier. This is how you normally do a file when you save it. You save it as a STL, and then you push export here. And this is where it kind of takes some time. It's generating that file and going through the cloud to save this stuff for you. That's what Fusion 360 is, kind of a cloud-based software versus you know, something like Inventor or one of those that is a huge program that's literally installed on your computer or on your network or something like that. So anyway, that's all. This is just saving a file. You don't need to see that, but normally you would pull up this software that I was just showing you. This is another version of it. It's pretty close to the same thing. And then you would just pull in file. Things I've made in the past, something like that. Just pull this up. I think I made this, I forgot what I made this box for. Store batteries in, I think. I can't remember. Anyway, that doesn't matter. I made some of these kind of boxes. I don't know if you can see that. To store batteries in and stuff in my desk here that way. I like it because, you know, my wife's always digging around. We got any AAA batteries? I'm like, I don't know. So I paid these boxes. And I said, when these boxes are getting low, just get some more and fill it up. And you can always see, you know, when you need batteries, when the grandkids come over and they need batteries for their toys and stuff, you know. So anyway, I don't remember. I built this little box for something. Maybe it's at work. I don't know. But that's how you pull that up, and then you just push slice, and that's how that works. That same way that we've saved that file there a minute ago. So it saves, and you can close that, and then it'll let you close the whole program out. And it's asking, do you want to save it? I don't care if we save it or not. I've made this file a few times trying to show you. You know, this is my second or third attempt at showing this on a video, and I've learned a little bit more every time I've done it about using this software and using this screen recorder that I don't know if it's even working for sure or not, but anyway, hopefully it is. And I'll show you some video here in a minute of making this part and the ones I've already made, so see you in a minute. So here's a 3D print working right now, making what we drew up. It's going to take it about 4 hours or so. And it's pretty simple. You just put your card in here, pretty much pull your file up and print it. Now, there's a few other things to learn. And here's the things I've been making like this. So that's what it is to do it.